With our ever-growing population, there is a dramatic strain on our natural resources. From 6 billion people in 1999 to 7.24 billion in July 2014. Every day our population grows further, and you can watch this real time at worldometer.com. These people both want and deserve the comforts of a modern world. But at what cost? Fossil fuels are a finite resource, meaning that eventually they will run out. Now, you might say, who cares? Well, in fact, you do. Without them, we'd have no planes, cars, plastics. In fact, you wouldn't even be able to watch me on your laptop right now. A catalyst is a material described as something that will increase the rate of a reaction without itself undergoing a permanent change. And in fact, they're all around us, from fermenting in beers to biological catalysts that are inside you called enzymes. Now, how do they work? Well, imagine there's a mountain, and the peak of this mountain is the energy required for you to start a reaction. We call this the activation energy. A catalyst lowers this activation energy by stabilising the transition state. Essentially, it builds a tunnel between A and B. Catalysts can increase reaction rates by a factor of 10 to the 10, meaning if it took you 1 second to walk through the tunnel, it would take you 3,000 years to go over the mountain. Now, one way to catalyse a reaction is using heterogeneous catalysis. A good example of this is a catalytic converter, shown by a nice animation I've taken from ChemWiki. It removes harmful pollutants from exhaust fumes, and it does this by oxidising carbon monoxide to form carbon dioxide, reducing nitrogen oxide to form elemental nitrogen and oxygen, and turns nasty hydrocarbons into both CO2 and water. Biodiesel is an excellent example of a biorenewable fuel. It takes waste products like chip fat from your local fast food joint and turns it into fuel your car can run on. Not only that, but it has a high oxygen content, somewhere between 11 and 15%, meaning it makes less CO2 and less soot for your car engine. 70% of biodiesel is made by a process called Tranced esterification, which uses a homogeneous catalyst, meaning it's in the same phase as a reaction, so in this case, liquid-liquid. So how does it work? We take our waste chip fat, or triglycerides, and react it with an alcohol. Now that's not the type you can drink. It's often methanol, so it could blind you. With this, we also add an alkaline catalyst, such as sodium oxide or sodium bicarbonate. This forms an alkyl ester, our fuel, and glycerol. The reaction itself proceeds by an SN2 mechanism, basically meaning that we swap or substitute our glyceride group for this part of the alcohol. The basic conditions deprotonate our methanol, giving its oxygen a negative charge, which it uses to attack the carbonyl group and bond to the carbon. The negative charge is then transferred to the oxygen of the carbonyl group. This oxygen then pushes its negative charge onto the glyceride group, kicking it out to form our alkyl ester, or fuel in this case. The glyceride is then protonated to form glycerol. After some separation, neutralisation with water, and drying, our fuel is ready to use. Like many processes, there are some issues. Because of where our triglycerides come from, they contain impurities. Impurities formed by the hydrolysis of oils, and they're called free fatty acids. They react directly with our catalyst to form soaps, and not the nice smelling kind. This reaction deactivates our catalyst, rendering it useless. To such an extent where 3% of the starting material by weight being free fatty acids will cause the reaction to not occur at all. So scientists have begun to study heterogeneous enzyme catalysts. It makes it much easier to separate the catalyst from the end product, and also removes any need to purify it, meaning you can use it instantly after the reaction. Who knows what the future holds? Maybe one day you might be able to take oil out of your frying pan and make it into biodiesel instantly to run your car. Thanks for listening.